Hi students, welcome to MATH4U. Today, let's see what are real numbers and the decimal expansion. So real numbers, you have already learned the rational and irrational numbers, right? So here, by seeing the decimal expansion of a real number, how can we recognize whether it is a rational or irrational numbers? That is what we are going to discuss in this session. So find the decimal expansion of the following. So here we are going to do the decimal expansion of some numbers. That means let us go ahead by checking 1 by 4. I'm going to do here the long division method, that is 1 by 4. You know 4 will not go in 1, so we have to put 0 and it will be like 2 4s are 8, then 2 is coming remainder, again put 0 0 2, 5s are 20. Okay, so the decimal expansion of 1 by 4 is 0.25. Let's see the decimal expansion of another one number. So let me do here 13 by 5. Okay, so 13 by 5, when we do the long division method, let's see how it will be. 2 times 5 will go with 10, then 3 is the remainder. We don't have here more numbers to take, so we are putting 0 point, then 5 6 are 30, so it is done. So the decimal expansion of 13 by 5 is 2.6, right? So now one more, let's see. So here I'm going to do the decimal expansion of 2 by 3. That is by long division method. 2, 3, you know how to do now. So I'm not explaining. So how many times 3 will go in 20? 6 3s are 18. Then again 2 will come. You have to put 1 0. 3 again will go with 6 times. 18 again 2 again 0 you have to put. It will become 20. 6 again 18 2. So this process is repeating, right? So the decimal expansion of 2 by 3 is 0.666, etc. That is repeating going, right? So let's see from these three examples what we have done for the decimal expansion of 1 by 4, 13 by 5 and 2 by 3. We have seen that for 1 by 4 and 13 by 5, the decimal expansion ended. That means the remainder we got it as 0. But in the case of 2 by 3, we have not received 0 as a remainder. It's keep on going, right? We will get 2 as a remainder. Again, we add 0. Then again, the answer is going like 0.6666 like that, right? So let's conclude this. What is terminating decimal? So every fraction p by q can be expressed as a decimal, right? Every fraction, now we have done with 3 examples, all have end with a decimal number as we have done now. If the decimal expression of p by q terminates, that is comes to an end, then the decimal so obtained is called a terminating decimal. So if it ends means we are talking about if the remainder is 0. For the first case and the second case, you can see here the remainder came as 0. So in that case, we will say that this is a terminating decimal. That means it came to an end, right? So as an example, we have done in the previous question, it can see that here 13 by 5 and when we did for 1 by 4, the remainder is 0, right? That means it is a terminating decimal. So if it comes as a terminating decimal, we can say that it's a rational number. So this is how we can recognize a rational number in one way. Okay, so real numbers, by seeing the decimal expansion, how can we recognize? So if it is a terminating decimal, we can say that it's a rational number. Okay, now another one thing is a fraction p by q is a terminating decimal only when prime factors of q are 5 and 2 only. That means if I'm taking one p by q form, okay, let me take 5 by 32. You can see this is now of the form p by q. Here q is 32, right? So let's see whether the prime factors of 32 are 2 or 5. So you can see here when we do the prime factorization, you will get 32 as 2 raised to 5. So here you can recognize that the 32 has no prime factors other than 2, right? The prime factors is only on 2. So can we say that this is a rational number? Of course, because this is a terminating decimal. So we have seen either if it is on 2 or 5, we can say that it is a terminating decimal or a rational number. Okay, is that clear? Yeah. So let's go ahead with the next one. That is called a repeating or a recurring decimal. What is called this a repeating or recurring decimal? When we see in the first case, when we did the expansion, decimal expansion, that is for 2 by 3, when we divided through long division method, you have seen here the answer is 0.666, like that it is going. What does it mean? How can we call it? So let's see. So I'm writing here that decimal expansion, that is when we divided 2 by 3, you got the answer as 0.666, etc. So we will write this type of numbers 0.6, a bar over a line over the number which is repeating. Okay, so a decimal in which a digit or a set of digits repeats periodically is called the repeating or a recurring decimal. So this is called a repeating or recurring decimal. Here 6 is a repeating, right? So this type of decimal is called a repeating or a recurring decimal. Another one example we can see here, if you are dividing 3, so if you divide 3 by 11, you can see that this is 0.272727, like that. So this is we can write it as 0.27 recurring. Okay, so this is called the length of the period. Length of the period. So repeated number of decimal places in a rational number is called the length of its period. So here the length of the period, I will write over here length of a period. Here the length of the period is 2. According to this, length of the period is 2. Here the length of the period is 1. You can see here only one number is repeating, that is why length of the period is 1. And here two numbers are repeating, that's why you got the length of the period as 2. So this is how the two ways to recognize whether it is a rational or irrational number by seeing the decimal expansion. So in the first case, it terminates. That means the remainder is 0, or you can see when it writes in the form of p by q, take the prime factorization of the denominator and see whether it is ending in 2 or 5, then also you can recognize whether it is a rational number or not. Another case is if it is a repeating or a recurring. So same number is going on repeating, same pattern. Okay, so you can say that it is a repeating or recurring decimal and the number is a rational number. So let's go ahead with the special characteristics of rational numbers. This is the conclusion of what we have discussed as of now. So every rational number is expressible either as a terminating decimal or a repeating decimal. So as I discussed now, we can recognize a real number whether it is a rational or not by checking the decimal expansion. If it's terminating or repeating decimal, we can say that is a rational number, right? So the second one is every terminating decimal is a rational number. That is the same thing, okay? And every repeating decimal is a rational number. So if you keep in mind in the first one, you can understand the second and third easily. Okay, so let's go ahead with the irrational numbers now. Irrational numbers are can be either neither be expressed as a terminating decimal nor as a repeating decimal. Okay, it's just opposite of the what we have learned for rational numbers. It cannot be represented either in terminating or a repeating. So then how can we represent it? Non-terminating, non-repeating decimals. What is called this non-terminating, non-repeating decimals? Any idea? So let's take the example for irrational number. We usually talk about the irrational numbers like pi, root 2, etc. Right? So if we are taking those numbers as a pi or a root 2, how can we say that it is a recurring, I mean non-repeating, non-terminating? So let me write the root 2 and pi. So actually the value of root 2 is like it's going. It's not ending. 1.41, 42, 13, 56, 23, 7309504 8, etc. It is going like that. And the value of pi is 3.14159265358979. It's also going like that. Actually, when you look on these two numbers, you can see that it's not repeating, right? Any number is continuously, if it is as we have seen in the case of 0.666, this 6 is repeating same number, right? And one another example what we have seen is point, I think 27, yes, 0.272727. If it is going like that, we can say that the 27 is a repeating. But here in this case of irrational numbers, you can see that it is not repeating, non-repeating decimals, and it is not going to an end. That means non-terminating, non-repeating decimals. So those type of numbers we can consider as irrational numbers. Okay, irrational numbers. And one more thing, don't get confused, like why can't we write, we are writing, used to write with pi as 22/7, and when we go the division of this one we will feel like that is a rational number, right? So it's actually an approximate value what we used to take for applying in some problems. Actual value of pi is this one, 3.14159265, etc. And root 2 also you can see that this is the actual value. That is how it comes under irrational numbers. So if for example, if you are getting a number when you divide, the number is of the form, it's let's say it's like 0.10110111011110, etc. like that is going, we can say that this is a non-terminating recurring. So it will also go under irrational number. So I hope it is clear how to recognize a rational number and irrational numbers by seeing the decimal expansion of the real numbers. Is that clear, all of you? I hope it is very clear. Thank you.